recent years, Betelgeuse has kept the scientific community on edge with its dramatic fluctuations in brightness, leading some experts to speculate that the red supergiant's explosive end might be near. However, the right shoulder of Orion has once again captured the attention of astronomers. One theory posits that Betelgeuse is rotating much faster than anticipated, possibly due to having consumed another star in the past. Another possibility is that the massive star could be part of a binary system. If Betelgeuse does indeed have a companion star, why has it remained undetected? Could its existence help resolve a key astronomical mystery? In our minds, the Sun often symbolizes the ultimate celestial giant, and with good reason. Our Earth could fit into the Sunday January 3rd million times, and its diameter of nearly 1.4 million kilometers is undeniably impressive. Yet, when compared to far larger celestial bodies like Betelgeuse, the Sun seems almost small. Located around 650 light-years away in the Orion constellation, Betelgeuse dwarfs the Sun in every aspect. Its diameter is 800 times larger, and its brightness is a staggering 10,000 times greater in visible light. Despite its immense luminosity, Betelgeuse surprised scientists 5 years ago when its brightness suddenly dimmed over a period of weeks. The dimming was so significant that it was visible to the naked eye, prompting speculation and debate among astronomers. While periodic brightness fluctuations are normal for Betelgeuse, this particular event was much faster and more intense than usual. Astronomers use the magnitude scale to measure brightness. Lower magnitude values indicate brighter stars. Betelgeuse typically has a magnitude of 0.3 to 0.4, ranking it among the 6th to 7th brightest stars in the night sky. This extraordinary star continues to intrigue scientists and skywatchers alike with its ongoing mysteries and cosmic grandeur. In December 2019, Betelgeuse underwent a significant dimming, with its brightness dropping to 1.1289 magnitudes, placing it 21st in the brightness rankings. This unexpected event led to further speculation. Could Betelgeuse be on the brink of becoming a supernova? As a red supergiant nearing the end of its stellar life, it was natural for some experts to associate Betelgeuse's dimming with an impending explosion. Normally, Betelgeuse shines 10,000 times brighter than the Sun, but during a supernova event, researchers predict its luminosity could increase by 16,000 times. In such a scenario, the star's apparent brightness would range from -9.5 to -1.5 magnitudes, comparable to the full moon's brightness, making it visible even during the day. However, the timing of this potential spectacle remains uncertain. Most experts now believe that a supernova is not likely to occur in the near future. What was initially interpreted as a precursor to a cosmic explosion was later identified as a massive plasma eruption. This eruption generated an enormous dust cloud that obscured Betelgeuse, reducing its brightness by nearly 2/3 as seen from Earth. As a dying star, Betelgeuse regularly ejects significant amounts of stellar material. Convection currents transport this material from the interior to the surface, where it is expelled into space. The star also undergoes 400-day cycles of expansion and contraction. Experts suggest that the unusual dimming was caused by a combination of strong convection and a particularly intense plasma eruption, estimated to be 2 to 3 times stronger than usual. For context, during this event, Betelgeuse's mass loss rate was approximately 30 million times greater than the Sun's. The expelled plasma likely cooled in space, forming a massive dust cloud. When this cloud aligned with the line of sight between Earth and Betelgeuse, it caused the star to appear veiled and significantly dimmer. This phenomenon serves as a reminder of Betelgeuse's dynamic and unpredictable nature as it approaches the final stages of its stellar life cycle, continuing to captivate both astronomers and enthusiasts alike. In addition to its erratic brightness, Betelgeuse has also intrigued astronomers with its puzzling rotation. Recent images taken by the combined radio telescopes at the ALMA Observatory revealed that the red supergiant is spinning at an astonishing speed, over 5 kilometers per second, which is 50 times faster than expected for a star of its type. This rapid rotation challenges typical stellar behavior, as stars usually slow down as they expand. Jing Ma from the Max Planck Institute for Astrophysics in Garching, Bavaria, notes that Betelgeuse is the only known red supergiant believed to rotate this quickly. This unusual rotation is thought to be related to the star's bipolar surface structure, where one side exhibits a blue shift and the other a red shift, with each shifting by several kilometers per second. To explain Betelgeuse's surprising rotational behavior, astronomers have proposed an intriguing theory. The star may have become a cosmic cannibal. According to this theory, about 100,000 years ago, as Betelgeuse expanded into a supergiant, it may have engulfed a companion star similar to the Sun. The idea is that when Betelgeuse consumed this star, it transferred the companion's angular momentum to Betelgeuse's outer layers, accelerating its rotation. This hypothesis is supported by both computer simulations and observational evidence. Images taken by the Herschel Space Telescope a few years ago revealed two zones of ejected stellar material on one side of the supergiant. Initially thought to be signs of an impending supernova, these shell-like structures are located almost precisely at the distance where they would be expected, based on Betelgeuse's rotation and mass loss. This suggests that the rapid rotation may indeed be a result of Betelgeuse's past encounter with another star, adding another layer of mystery to this captivating celestial object. Following this stellar cannibalism theory, other possible explanations for Betelgeuse's rapid rotation have emerged. MA's research team suggests that the star's surface is covered with massive plasma bubbles, which rise and fall across large portions of the outer shell. The movement of these bubbles could create the observed red and blue shifts in Betelgeuse's radio emissions. Essentially, it is possible that Betelgeuse is not spinning as fast as it appears. Instead, it could be creating an optical illusion. If one or more large convection bubbles are moving toward the observer while others are moving away, even a non-rotating star could appear to be rotating at high speed. A recent analysis of ALMA data, combined with an astrophysical model, supports this theory. According to Ma, there is a 90% chance that the apparent high rotation rates observed in the simulations are a result of misinterpretations caused by the low resolution of the ALMA images, which distort the true movement on Betelgeuse's surface. As a result, the exact rotation speed of Betelgeuse remains unclear, and the likelihood of the stellar cannibalism scenario being accurate is still uncertain. What is becoming clearer, however, is that Betelgeuse may not be alone. As mentioned, Betelgeuse experiences a 400-day pulsation cycle, but it has not yet fully recovered from the massive plasma eruption of 2019. The eruption's aftereffects continue to induce rapid oscillations within the star, causing its surface to vibrate like an oversized jelly. Astronomers believe it will take several more years for Betelgeuse to return to its normal rhythm. In addition to its 400-day pulsation, Betelgeuse also exhibits a secondary, longer cycle of brightness fluctuations that occurs every 2,170 days, or nearly 6 years. For some time, the cause of these long-term fluctuations remained a mystery. However, Jared Goldberg and his team at the Flatiron Institute in New York recently revisited all available observational data on Betelgeuse, leading to new insights. Their analysis revealed several unexpected anomalies, one of the most striking being that the 6-year cycle in the star's light curve follows a different rhythm than the 400-day pulsations. Specifically, the long-term fluctuations are out of sync with the shorter cycles. Moreover, the researchers could not identify any accompanying phenomena, such as rotation sequences, magnetic field effects, or convection currents, that could explain these fluctuations. After careful investigation, the team concluded that the only plausible explanation for these long-period oscillations, without any major flaws, is the presence of a smaller companion star. According to this theory, the 6-year fluctuations correspond to the orbit of the companion star. When the companion is positioned behind Betelgeuse, as seen from Earth, the star's brightness is at its lowest. On the other hand, when the companion is beside Betelgeuse, the combined luminosity of both stars causes the brightness to peak. Furthermore, the companion star may also influence the distribution of dust clouds around Betelgeuse, which could contribute to the fluctuations in brightness. However, the presence of this companion star remains elusive. The most likely reason is its low mass, around 1.7 solar masses, compared to Betelgeuse's nearly 20 solar masses. Additionally, the companion star likely orbits very closely to Betelgeuse, at a distance of only 2.43 times Betelgeuse's radius. This close proximity means the companion is overwhelmed in brightness by the much larger Betelgeuse, and the star's pulsations and brightness variations make it even harder to detect. While the chances of spotting the companion star with current telescopes are slim, the researchers plan to apply for observation time at larger telescopes in hopes of uncovering more evidence of its existence, and possibly learning more about the type of star it is. Stay tuned for further updates. Don't forget to like and subscribe to our channel.